Hello and welcome to Eaton's Technology Summit for Data Centers and Energy, coming to you from Madrid. I'm Emma Strutton, I'm Head of Channels at DCD, and I'm delighted to be joined by Linsey Miller, who is the President of Global Distributed IT at Eaton. So thanks for joining me, Linsey. How are you?
Good, how are you doing?
Yeah, I'm very well, thank you. So to start off with, are you able just to tell me a little bit more about you and your role at Eaton?
Sure. So I lead our distributed IT organization, which serves a range of customers from enterprise to edge to hyperscale and colo accounts all around the world. And we have a mix of technical product manufacturing resources that are designed to support those customers through all the chaos and fun that we're enduring in the data center industry right now, and with enterprise workloads and just the rise in computing and AI processing.
Yeah, fantastic. And kind of you mentioned that the chaos and fun of the data center industry at the moment. We are, of course, seeing huge demand at the moment for scalability and greater capacity for AI. So why do you think traditional data center construction is struggling to keep up with that level of demand that we're seeing at the moment?
I think the whole cycle is just being compressed. We went from an environment where we were in a 3 to 5 year build time frame that's now being compressed to 12 to 24 months. And there's just overwhelming demand for the amazing breakthroughs that AI is enabling by end users and also by the operators, and their need to get to revenue generation as fast as possible to meet that demand. And we don't always have access to all of the infrastructure that we need in any given data center site, whether it's labor or availability of power and infrastructure that's needed to bring those sites up. And so it's creating this shift toward modularity and the ability to assemble those sort of prefabricated solutions offsite and bring on-prem faster in order to get those sites going to meet the demand. So it's really a pivotal time right now, and it's exciting to be in the midst of it. But while we're also seeing the compression of those build cycles, we're also seeing some really amazing innovation at the engineering and design levels as well.
Yeah, absolutely. And speaking of those innovations, when it comes to that speed to market, how are modular data centers evolving and kind of maturing into fully integrated platforms?
Yeah, it started actually with the modularity being more of the structures or the pods around those different elements of the data center, from the grid interconnect to the gray space to the white space data hall, moving into more integrated solutions with all of the power infrastructure inside of them. And so they've become more dense and more kind of capable of being, I guess you'd say, like server ready or GPU ready or chip ready. And so the integration has gotten a lot tighter. One of the reasons that we bought Boyd was for their liquid cooling capability. Yeah. When we basically, if you look at the NVIDIA chipset, we kind of passed a point of no return in even 2023 with, H100s exceeding 50 kilowatt racks, where we could no longer cool all of that compute without liquid cooling.
Yeah.
And many of the data centers that exist today have air-cooled environments, but they need liquid cooling in order to go to the next generation of GPUs. And so it's really hard to go in and retrofit that. But if you can do that on a modular level, and you can take those modular solutions and you can include the power distribution infrastructure as well as the cooling infrastructure in one contained pod, which we do with our skidded hacks and with our modular white space solutions from Eaton, you can actually get going a lot faster to meet the demand for those workloads. So it's pretty exciting to see this happening and to be able to help customers that are in this hybrid environment where they started with maybe a brownfield data center environment that has certain limitations around power and cooling, but now with modular solutions, they're able to enhance them and drop in more modern solutions to meet the latest generation of GPUs.
Yeah, fantastic. And when it comes to reference architectures as well, how are those acting as a catalyst as well for accelerated rollout?
Yeah, reference architectures, they've been around for a long time, even with, prior to GPUs, just CPUs, right? Intel forever. Like I started out in the computing and motherboard industry, and Intel would release a processor, and we would create motherboards to go with it. Now we're doing the same thing with GPUs. So the GPU vendors have reference architectures, and they're dependent upon an ecosystem of partners to build out that the power infrastructure and the power distribution that's necessary to bring it to life. Eaton is obviously, one of those ecosystem partners to NVIDIA as an example. So at GTC this year, we announced our Beam Rubin DSX, and that basically took reference architecture to, from a very simple state back when reference architectures started to being a complete data center design. And what it means, DSX is an entire data center reference architecture. So grid interconnect, gray space, and white space solutions, all as one, with a digital twin capability that our customers can design in the Omniverse, which is basically, I liken to like Minecraft, where you go in and you see all the Eaton parts and you design your data center.
Yeah.
But you can also do the power simulation to see, okay, when I design this data center and I bring it to life, what is going to be my future OpEx? What are going to be some of my challenges that I need to think about? And it really is an exciting time to be able to have customers that can do this digitally and can build reference architectures, not just at the discrete level, but at the complete macro level.
Yeah, fantastic. That's so impressive. And, we've talked a lot around, the importance of scaling out speed, but how can the reliability, compliance, and operational efficiency be maintained as well?
That's a good question. I mean, like if you think about it from the perspective of a data center operator, it's all about uptime. We serve mid-sized businesses where 1 minute down is $14,000 a minute.
Yeah.
Or larger enterprises can be over $23,000 a minute. And so it's all about uptime and reliability. And for us, we think about the entire power chain. So not just the solution next to the chip, but everything emanating from that and to that in the power distribution. And so we need to think about things like, how are we handling AI pulse loads when the servers are sitting idle, and then all of a sudden, you send it a query, or you're doing research and you have multiple GPUs acting in clusters together, suddenly the workloads rise. So we have capacitor solutions throughout the power chain to manage the workload, but we also have solutions around the breakers and the entire DC distribution to really ensure that we give our customers the best uptime. So Eaton's thinking about it from a holistic point of view, and going from the pain point of the customer uptime, working our way back into the solution at every level to ensure we maximize uptime is something that we do in design. And then also, as far as overseeing and connecting all of that, our Bright Layer software basically connects all of these different elements of the network and gives our customers that view, that God's eye view into, is everything running as it should? Are there predictive failure alerts that I can monitor and I can handle maintenance for in advance of problems? That's essentially how we make sure that happens in real time after you get going in deployment.
Yeah, fantastic. And when it comes to standardization for accelerated rollout, how can we make sure as an industry that isn't limiting future adaptability as well?
Yeah, well, I've always been part of industry standards, I think, since my very first job in technology, and I think they're essential for progress.
Yeah.
And right now, we're in the middle of a shift to a completely different power architecture with 800 volt DC. And it's essential for us to effectively meet the demand of AI workloads, but it also has to be safe. So, you know, if you ask the question like, are there ever too many standards? Yes, maybe sometimes it can get to be a lot of work and administration to keep up with, but we need data center operators who have never interacted with this level of direct current to be safe. And that's why we work with UL and IEC and Open Compute Organization and the standards bodies to, you know, make the progress that's needed, but do it as fast as possible, as safe as possible. And so Eaton has a lot of great technical leaders that are involved in that work, but it's absolutely essential so that the whole industry can basically come together and make sure that we are ready for these architectures and that we are prepared for the worst case scenarios.
Yeah, yeah. Fantastic, thank you, Linsey. And to round us off, you know, what are your predictions for how modular data center construction will evolve over the next year?
I think things will continue to become more dense. We will see increasing power density. We will see more liquid cooling, and we will see more integrated blocks to solve for that. And I think over time, the power architectures will continue to evolve and innovate such that we can make more room for the IT workloads so that the data centers as well can become more dense to handle more AI computing at every level. I also think that those innovations will essentially kind of get democratized into the edge as well. And we will see more edge processing for AI at smaller scales, drafting off some of the innovation that we've seen in the data center. So it's a really exciting time for every organization. I mean, if you owned a factory and you were able to put robotics in place, you would need edge processing in order to enable that to happen. And you may want to actually handle that on-prem. Or you might be a government who has a sovereign data requirement and you need to host that data and that processing on-prem. You will start to do more at the large enterprise level that we've traditionally done it in data centers, but in both environments, we will see increasing power densities, increasing AI compute capabilities, and just incredible innovation as far as, you know, how you handle that those thermal demands that come with all of that power and all of that increased compute processing. Yeah. So it's an exciting time, and I think we'll see more and more of it, and we'll see more modularity to come with it as well.
Yeah, fantastic. Well, great note to end on. Thank you so much for joining me, Linsey. It's been a pleasure speaking with you.
It's
Thank
great.
you very much.
Thank you so much, Emma.